started. How is everyone going? Doing? Hopefully everyone is great. This is our biggest Elixir conference EU ever. So thanks everybody for coming. And I want to give a huge thank you to the organizers. Woo! So if I look a little bit tired, is because I live in Poland and I traveled by bus. Yeah, there's an airline called Bus. All right, let's get this started. So last year, my keynote at Elixir Europe was my future with Elixir. And the idea there was to talk about, to motivate all of us to think, as Elixir was its 10th birthday, to think, what is our own future with Elixir and where we want it to go? And for me in particular, there are three main areas of interest. And those are the areas that I said last year that I was interested in: set theoretic types, developer and learning experience, and machine learning. And last year, I talked a lot about set theoretic types. That was the focus of the conversation, more about types in general than set theoretic types, but we talk a lot about typing, why we may want or may not want to have types in Elixir. But today, I want to focus on the developer and learning experience, okay? And, so I want to focus on the developer and learning experience, but I know that many of you are probably very excited to hear about some updates that we may have on the type system front. And Elixir 1.15 is also going to be coming out next month, so you may be interested in knowing what is happening there. So the plan for today is that we're going to talk about Elixir 1.15. We are going to talk about some brief updates on the type system effort, and we're going to then finally talk about the developer and the learning experience. I'm not going to talk about machine learning today, but we are starting to have more and more talks and materials coming up in the community. At the event, I believe we have at least 2 talks from Lars and Jonathan. So if you're interested in the machine learning front, I recommend checking them out. And let's do this. So Elixir 1.15 is going to be our most boring release ever. All right? If you go check the changelog, yeah, right? If you check the changelog, there is not really many exciting things coming. We have, of course, we improved the API here and there, added some small functions. So it's our most boring release ever, except if you have a large code base, if you have a large application. Who here is working on, maybe you don't want to say, but who here is working on a code base with more than 1,000 files? All right? Yeah, this release is for you. So just to show some numbers, totally non-scientific, I ran this for Livebook, which is an application with 200 files, but we have run this also, well, I'm going to tell you more soon. But I ran this on my machine, all right? So this is the time to compile a project, right? And in Elixir 1.14, OTP25 for Livebook running on my machine, it takes 6.4 seconds. Just migrating to Elixir 1.15, it goes down to 6 seconds and about a 7-8% gain. But if you use the combination of Elixir 1.15 and OTP26, it's down to 5.3 seconds. And so again, it's not a large application in this case, 200 files, but we have run, some people are trying it out and giving feedback where they're seeing numbers up to 40% faster compilation time for really large applications. Why does everybody have an alarm at the same time? Yeah, so this is a nice improvement, 20% faster, give me any time. Let me see if we can make it blink less. All right. And, And then it's not only compilation time that is faster, we're also improving the time for you to get the feedback. So I've also measured the time to do a mix run and evaluate the number 1. It's not the evaluation part's not important. What is important here is that this is the time to boot your application. So every time you run a test, for example, you have to boot your application. So when we improve this, it means that when you do mixed tests, like a single test, because you are doing some like a development test cycle, The times are now better. So Elixir 1.15, OTP 25, it takes 1 second in Livebook. Migrate to Elixir 1.15, 10% faster. Migrate to Elixir 1.15 and OTP 26, it's going to be 30% faster. So always nice to get things faster, make our workflows more productive, and that's pretty much the focus of this release. And I've been talking a lot about Erlang OTP 26, and there are some exciting features in the next version of Erlang that is also going to come out next month that I want to talk about. So the first one is that they have a new terminal implementation. Who here develops Elixir on a Windows machine? All right. So yeah, this one is, there are dozens of us, yes. So this one is for Windows developers, right? And so I don't talk a lot about this, but when I started programming on Windows, and if it was, and the first, let's say my real professionally using programming language was Ruby. And at the time, the Ruby toolchain was maintained by one developer, Luis Lavena. And sometimes I think, if it was not this developer making Ruby work on Windows, right, my career could have been completely different, right? So we have a new terminal, and one of the big features in this new terminal is that it has aligned the experience between Linux and Windows for the terminal experience. So every time you use IX in Elixir, that's using the Erlang terminal. So they have implemented it from scratch. Amazing work from the OTP team, from Lucas. And the whole experience now is streamlined. Before they had an implementation for Windows, an implementation for Linux. So there were a bunch of differences. Things did not work the same. And now everything is streamlined. It's great. And that's also work that happened from Microsoft's side because Unix used virtual terminal, and Windows started supporting that 5 years ago. So everything is unified now, makes everybody's lives easier. Other features coming with the terminal. This has been asked a lot. People want to use Ctrl-Alt to clear the screen. It's going to work. And it also starts interactively. So for example, when you want to start IX in a project, you have to do IX-S mix. With OTP 26, we'll at some point finally be able to do something like mix IX, and then you're going to jump into IX. Or if you are in the middle of a test, if you are in the middle of a test and then you're like, hey, I want to debug this in IX, and then you add a pry, and then you run the test and say, hey, IX is not running. And then you have to change the command. Won't be necessary to do any of those things in the future. So very exciting. Also, some cool optimization work happening in Erlang OTP 26. They just published a blog post yesterday on the Erlang blog. But also, besides what they talk about, compiler optimizations, maps are faster in OTP 26. Maps of atom keys, which are most of the maps they are working on, right? All structs their maps with atom keys. And the reason why it's faster is because they changed how maps are represented internally. So perhaps the first thing that they are going to notice when you upgrade to Erlang OTP 26 is that some of your tests may break. And the reason for that is because, so when we have a map, it has keys in it, right? And the order of those keys is not specified. It can be in any order, but we can accidentally be relying on this order in our tests. So they changed the order so we get faster performance, and you may see that in your tests. But we also improved our tooling to make it easier to make sure that your test works on previous versions and new versions. So Chris, where is Chris? He's not here yet? Yeah, so Phoenix test is broken in OTP 26. So yeah, we also have some binary optimizations. So that's the blog post that the Erlang team talked about, some of the modules in OTP, base64 encoding is 2 to 3 times faster, which is really awesome. Oops. Yeah, all right. And the last improvement coming in OTP 26 is this is a contribution from us, is the code path cache. So when I was talking about those numbers, right, booting can be 30% faster, compilation 20% faster, is because of the code path cache work. So if you have a large application, it's likely that you have a lot of dependencies too. So for example, imagine that you have an application with 100 dependencies. The way it works is that each dependency is a directory. So when you want to load a module, like every time you first use a module, you have to load it into memory. It's going to go through those 100 directories trying to find that module, which means if you have more and more dependencies, right, the longer that's going to take. So we added a code path cache that the first time you look up a module, we are going to read we're just going to do like a list of files in that directory, get all the module names. So next time you have to look up a module, we are not doing a file system operation. Instead of doing like 100 file system operations, you're doing just one at the end, which is to read the module itself. So that's really nice, and that's a lot of the performance improvements that we are going to see when using Elixir 1.15 and OTP 26. All right, so that was the first topic out of the window, Elixir 1.15. And now let's talk about set theoretic types. So last year I announced we have a PhD scholarship to research and develop a gradual type system for Elixir. So it's a work that's being done by Guillaume, Beppe, and myself, really myself between quotes, because I'm not doing a lot of the work there. But yeah, and last year we announced this effort that has been ongoing. And the roadmap when it comes to the type system is that I consider it to be like a classic like research and development work, right? So there are like two stages. The first one is research. And the research that is happening here is that, well, we have two existing things. We have Elixir, a programming language that exists today, and we have set theoretic types, which is a theory that exists today. So the first step is try to see how can we fit those things together, right? Like we have to investigate, right? And we want those things to fit as closely as possible, right? That would be the ideal scenario, because if they don't fit completely, maybe it's not the correct type system for Elixir. And it has been like a great fit, but nothing is going to be like 100% perfect fit. Sometimes because it just can't be. Sometimes because we have to develop new theory. We have to improve the theory to model some of Elixir features. So we have to find those areas of incompatibility, and we have to augment the theory whenever necessary. And then finally, when we do all those things, we're probably going to publish our results and collect feedback. So I am really glad to say that we are at the very end of the research stage, right? We did all those things. We mapped Elixir to set theoretic types. We found areas of incompatibility. We developed, not me, Guillaume and Beppe, augmented the theory whenever necessary. And we are towards publishing the results. So we're going to have some papers published over the next weeks. And we are also collecting feedback. So for this purpose, both Beppe and Guillaume, they are here at the event. So if you are interested about types, go talk to them. Guillaume is going to have a presentation later today called Bringing Types to Elixir. So go check it out. So we don't have types in Elixir yet, but if you want to know how the theory works behind the types and how it could potentially look like in the future, go check out Guillaume's talk. And I'll recap that this work is only possible because it's a partnership between the CNRS and Remote. So Remote was here on the stage earlier today. Go check their booth. And it's also being sponsored by Fresha, who also has a booth at the event, Supabase, and Dashbit. So I just want to quickly thank them for sponsoring this very important work for the community. Yeah, and then the roadmap, if you're out of the research stage, right, we're just coming out of the research stage, the next step is going to be development, right? We're going to start finally integrating some, the set theoretic type system into the Elixir compiler. So that's going to start in the second semester of this year. We initially focus on patterns and guards, and we are looking for sponsors. So we are very thankful for the sponsors that helped in the research stage. Now we are starting this new stage, and if you are a company who is interested in sponsoring this work, please reach out to me. That's it. I won't talk about type systems today. Go check the Guillaume's talk. Or if you're not familiar with the topic, you can check my presentation from last year. Now it's time to talk about the developer and learning experience. So focusing on the developer experience is nothing new for Elixir. We have like focused on this since the beginning. That's why we have tools like Mix, Xdoc for generating documentation, hacks, right? But as Elixir has become stable, we have been able to put more and more energy towards, like, let's say we're putting more cherries on the cake, all right? So for example, the recent release, we added DBG. Yes, it's print-based debugging, but it's pretty awesome at it. It improves the workflow a lot when you want to inspect a pipeline or when we have to see what multiple parts of the code is doing. We added mix install. So mix install, Elixir before, if you wanted to try a dependency, you had to create a mix project, list the dependency, and then start playing with it. With mix install, you can just, like in IX or in a notebook, you can immediately install a dependency and play with it and see what it is about. We have worked with mix format plugins. So we have the formatter for probably, 6, 7 years. And we added this idea where you can have plugins in the formatter. So now if you're working on a Phoenix application, with the same command, you can format all of your Elixir code and all of your markup too. And that's pretty awesome. I use this all the time, and I really love it. Don't have to worry about like formatting the code manually. Doesn't matter if it's HTML, it's Elixir, whatever. And we also worked on low-level tools like compilation tracers. So if you're building, for example, like a language server, or if you're trying to make something that really tries to understand how the Elixir compiler works, we've added these compilation tracers, which allows you to hook into the compiler, learn more about it. And we also worked on this thing called code fragment, okay? And the challenge with working, for example, let's imagine we want to improve the IDE experience. So the Elixir compiler, it's like, if you forget to close a tuple, we'll be like, I can't compile that. Like, you didn't close that tuple. Please go and close it for me, right? So we work with complete code. Like, the code needs to be complete, needs to be valid. But an IDE is not like that, right? Like, you open a tuple, you start typing, maybe the code doesn't make sense, but you want to get suggestions about what are the variables, the functions, right? So an IDE needs to deal with fragments of code, hence code fragment. And we have been working on these ideas within Elixir itself. We're starting to bring more concerns that an IDE would have, and they would try to understand about Elixir code. We are trying to bring it to Elixir to make the lives of everybody who is working on those tools easier. And we use this now in IX, in the Elixir language server, in Livebook. And Dashbit has hired Łukasz Samson to work part-time on improving the language server and the tools that use it. Something else that I'm really proud of the community that we achieved. So GitHub has this feature called code navigation, and you can see that code navigation was enabled for Elixir. Probably, they don't have a date here, but I think it has been more than a year. And this was really cool because before, if a language had code navigation on GitHub, which means like you can go click on the modules or you can click a function and see where it's defined and other places that use it. All the languages that were supported before were languages where GitHub went and implemented the features themselves, like the GitHub team. But the Elixir community was able to stand up and implement everything that was necessary to bring code navigation for Elixir. And then we reached out to the GitHub folks and they incorporated that. And GitHub did a blog post saying, now we have code navigation for communities, and Elixir was the first language that has paved the way for other languages to do the same. And I could go on and on and on and talking about like developer experience and learning experience, but how can we talk about developer experience if you're not going to be coding, right? So that's what I want to do. I'm going to use, if it all works out, I want to use the rest of the event to do some live coding and just show some ideas, some things I'm excited about. All right, so who here has used Livebook? Nice, really nice. So Livebook it brings computational notebooks to Elixir. It's very easy to install. You have like an installer, you just go double click and you have it running on Mac and Windows. So we have a desktop application. That's a better way of saying it. And Wojtek is going to be giving a talk on that today as well. So, and the idea about, well, I'm going to show you, right? So here I have Livebook running on my machine. Let's see if I can make this full screen. Yeah, I have Livebook running on my machine, and I think Livebook is going to continue playing a very important role in making Elixir more accessible And also, not only from the learning experience point of view, but also about allowing the community to grow and learn about new tools, right? So I have a live book running on my machine, and I prepared this notebook for today's presentation, and that's how it looks like. So we have some notebook here, and a notebook is a place where you can basically mix code and documentation and prose, right? So here, the first thing that we do is a mix install. I have a bunch of dependencies that I have to install for this notebook. And I ran this before, so everything is cached. And now I can start playing with some code. So for example, imagine that we want to teach somebody about Elixir. At some point, we're going to talk about processes, right? Because processes are a very important thing, very important abstraction for Elixir. So we probably say, hey, you can create 1 million of processes. Well, is that true? We can just click here. By the way, in the back, is the font size good? Can you... Perfect. There in the corner, good? Fantastic. Right, so you can say, hey, you can create 1 million of processes. And yeah, we can literally do that. I can create 1 million of processes. I can come here and say, yeah, it took 2 seconds. It's meant to be faster, but yeah, it's going to be 2.5 seconds. And yeah, you can create 1 million of them, and it's going to be super, super fast. Right, and then later on, I'm going to say, oh, and those processes, they are all concurrent and isolated. And they are running at the same time. Like, so people have to start imagining those things, right? Like, oh, they're all running at the same time, right? And then you can say, look, and when they have to do something, they have to exchange messages, like they can send messages to each other. And then you can write this code. You can say, look, I'm going to spawn a child process, and what this process is going to do is that it's going to receive a message. It's going to receive a ping message with a caller, and it's going to send pong to the caller. So we spawn this process, and we store it in the child variable, okay? So that's good. And then we send the ping message to this child variable, and we are expected to receive a pong message. And if all this works, right, we are going to see it worked as a result. So we can execute the cell, and then it's like, oh, it's great. Another code sample. But because we are now in a rich medium, we are not like in the terminal anymore, we're not in IX, because we have a rich medium now as a browser, we can say, wait, so if I get the same code that is here, the same code, and I wrap it in a function called render sec trace, now we get this. We get a diagram showing exactly what is happening, right? So we don't have to imagine anymore. We can start showing things, right? It's like, oh, okay, I have a process which is self, is the current process, and we can see that it spawns that other process, and it sends a ping message, and it gets a pong message back, right? And it's not only about learning. So who here has used task async stream before to do concurrent parallel work, right? Great. Do you know how it works? How it's doing behind the scenes? Well, let's just call task async stream here. It's going to sleep for a random amount of time, right? And let's ask it to render the sequential trace. Okay? And now we can see, look, we have the current process. Let me increase this a little bit. We have the current process, right? And then you can see we expect at least 4 other processes, right? Because I said, look, we are running things concurrently, and the concurrency is of 4, the number 4. And then we can see here, okay, and they are sleeping for a random amount. So you can see like this one started, and then it finished here. The last one seems to be the shortest one. It started and then finished very quick. We can start getting an idea, right, of how it would work if we're doing something concurrent, either CPU or IO based. But as I said, we're expecting to have how many processes here? The current process, right? And then 4 others. But we have 6 processes here. We don't have 5, we have 6. So you can say, oh, I can see. It seems that Elixir is starting a coordinator process that is responsible for starting all the other tasks concurrently, and so on. So we can start like playing with those ideas and build an intuition of how things work. And that's why I think it's like it's bringing Elixir to life, because now we're starting to visualize and get more information from our system in a much more accessible way than we ever did before. So, and we can show all kinds of things just with Livebook, right? And because it's a desktop app, just installing it is also very easy, right? So we also say, hey, now we have processes, and processes, they exchange messages. But the cool thing about that in Elixir, thanks to Erlang, is that we also get distribution because of it, right? We can also talk to different machines. So let's see an example, right? So I'm going to say, look, let's try to call distributed hello world, okay? We are trying to call the module distributed and the function hello world in it. Well, it doesn't exist. We get an error, right? But what if the module distributed is defined on another notebook, which, as we are going to see, is defined on another instance, right? Which could be on another machine. So I can go to this other notebook, and what I'm going to do here is that I'm going to, very simple notebook, it defines a module, and then it prints the node name and the cookie for that node, how we're going to access that node, right? So I can go back to this notebook, and I'm going to use Livebook to render inputs for us. So not going into details over the code, but we have this Keynote thing, we're going to talk about it soon, that allows us to define inputs. So we can define two inputs, one for the node, one for the cookie, and then we set the cookie for that node so we can call that module that we defined in the other notebook, so we can do the distributed communication. So I can come back here. I'm going to copy the node name. I'm going to copy the cookie. And now we are invoking the module from the other notebook. So hello world from another notebook, right? And then boom, we just show an example of distribution. We didn't have to fiddle with flags in the terminal in order to make that work, right? And we can go on and on. Maybe you want to teach somebody about a supervisor. So if you're using Mix, right, it has a supervisor called mix.supervisor. If I just have the name here, it says, yeah, that's an atom, right? That's Mix supervisor. But it detected that it is a supervisor behind, so I can just click here and see the supervision tree. That's how easy you can access the supervision tree now for anything. Or maybe we have Mix, right? This is an atom in Elixir, Mix. But we also know that it is an application. So if I want to see more information about this application, I just click here and I can see supervision tree, and we may add more things in the future. Right? So that's the idea, exploring what we need to do, everything's just more accessible. And the other cool thing about this is that we are been talking about processes, right? And it turns out that processes and distribution, the things that I have just been talking right now, is how Livebook works behind the scenes as well. So let's learn about that, right? Since you're here, let's continue learning. So one of the cool things about Livebook is that we can build collaborative things. And I'm going to build the intuition of how we can do that, okay? So the way it works is that, so one of the things that we have in Livebook is that we can have diagrams with Mermaid. So the way it works is that Livebook, which is the web application, is running Elixir, right, on one process of the operating system, right? And then each notebook, they have a runtime, which is another process of the operating system, right? So there are two different operating system processes, and then they communicate through the Erlang distribution. That's why when we did the distributed notebooks, right, it's like we had two different Erlang instances, Elixir instances communicating directly with each other over the distribution. And this is interesting because it brings the separation of concern where the code that you are running, the code inside the notebook, actually knows very little about Livebook. It knows almost nothing about Livebook. And in order to bridge this gap, we have this library called Keynote, which I've mentioned a little bit. We're going to go back to it. We have this library called Keynote that runs with your code, runs inside the notebook in order to teach it about Livebook things, right? So for example, let me give an example here. So when we talk about Keynote, every time we have like this kind of rich visualization here, like those tabs, we see those graphs being plotted. Those are always, or the inputs, those are all features contributed by Keynote. And most of the things that we have seen so far, right, they have been static. Like, yeah, we got the diagram, but we can't really interact with it. But the cool thing about Keynote is that it has two kinds of outputs. So when you have a cell, the cell can output two kinds of things, the static things that we have seen so far, like an atom, right? It's just like the result. But we can also create live outputs that we can like interact with it and broadcast information. So for example, let's do a counter, a very simple example. We're going to create a bidirectional counter. I'm not going to go through the code. We have this in our documentation. But these 50 lines of code, right? And then we have to render the HTML of the, well, let me evaluate the cell. So basically what we're doing is that we are creating a counter, 50 lines of code, not going to go over the details. But we can see here that we get a counter at the end, and then we can just go and bump it. And the cool thing is that if I start another session as another user, I could go into incognito mode, right? And then I come back to the same counter. somewhere. Yes, right? You can see that, it's collaborative, right? So not only Livebook in itself is collaborative, you allow like multiple users can like write a notebook together. It allows you to build collaborative applications too. Last week we did an announcement where we created a chat app using Livebook and machine learning, where you would say a message to the chat app and it would send to everybody. I'm going to show an example about this soon, right? So the idea here is that we have been like using it to debug our system, but we are only scratching the surface, because the way that we have debugging things so far, they're always static, but we can make everything now interactive if we want to. And the way it works is that if we build a little bit more in our architecture, is that each client, the browser, connects to Livebook using WebSocket. So everything is powered by Phoenix. It's using Phoenix LiveView. And so the WebSockets connect to the Livebook server, and then your code is running in a process. But each rich output that we see, like the counter, it's running on a process as well. So your notebook, in reality, it's all those processes that are interacting with the page, right? And we can build this cool stuff. So for example, let's see more stuff, right? So one of the cool things about the Erlang virtual machine is that it has a lot of great tools for observability, right? So we can list all the processes in the system, and then I want to get some information like how much work they have done, which is called reductions, their memory usage and status. And then we get this, right? We have a list of maps. Cool, we can work with this. But since we are in Livebook, what if we just put this on a table, right? And now we get a table with all the information, and we can go, if we want, we can sort it. We can say, oh, what is the thing that is using the most memory? We just come, we sort it, and we start having an idea and start interacting with the data, right? So there are a bunch of more examples that we can do about it. But in the interest of time, I want to move to the next topic of Livebook, which is smart cells. Has anybody used a smart cell before? All right. So, wait, this is a spoiler. This is not supposed to be here. Hold on. All right. So everything so far is like really nice, I hope you're enjoying it. But ultimately, right, we are still learning new APIs for everything. Yeah, you want to plot a table, you have to know that this Keynote data table exists. Oh, you want to do an input, you have to know that Keynote input exists. And you're hearing like, yeah, we can do machine learning stuff in Elixir, but you have to learn the libraries, right? You have to learn, you have to go through the documentation, go through the tutorials in order for you to get your first thing running, right? So yes, it's a brand new road. There's a bunch of exciting things, but there's also a bunch of learning. What if we could speed up this process, right? So for example, we have this information about processes here, right? Like we have the memory, the reductions. Well, what if we could, and imagine that now we want to plot it in a graph, right? Livebook can plot stuff. And now somebody says, hey, can we plot this? I'm like, yeah, we can plot it. And I would have to go and learn a new library. But with Livebook, we have the smart cell. So I can say, well, what I want to do is that I want to plot a chart. And I want to plot, so the data, it already picked up that the data comes from the process variable because that's the only plottable data that we have. So then we can say, okay, I want to plot the memory by the reductions. And I want to use the status as the caller for the process. So I just choose that. And then it started plotting some information, right? But it's not very helpful here because we have a process that is using a lot of reductions, a lot of memory. So all the processes here at the bottom, we cannot really distinguish them. So maybe we can come and change the scale a little bit to something like a log scale instead of being linear. And let's change here as well to the log scale. And now we're starting to look more and more at the data. We can increase the width here. And now we start to see some information about our system, right? Like, yeah, there is one process that is running, doing a lot of the work. And we have a lot of processes that are doing a lot of work and using a lot of memory. And again, we start building more and more intuitions about what is happening in our system. And the cool thing, and this is nice, right? But the cool thing about smart cells, like, well, imagine that you want to do something more with this chart. And it's something that We don't have an option here. You want to further customize it, you want to further extend it, but such option does not exist. What can we do? The cool thing about smart cells is that all they do at the end of the day is that they tell the notebook to execute code. That's all they do, right? And we can actually see the code that they are executing. That's it. That's the plotting library that we use. It's all here, which means that now if we say, hey, I want to customize this chart somehow, right? I can just convert the smart cell to a code cell, and I can go and change it like an Elixir code, right? And kind of start manipulating with it. And, I didn't say this, but Livebook functions like an IDE. You can get documentation for modules here just in place. You can get auto-completion, if I remember what is the shortcut. Well, let me do another example, right? So if you're doing enum, and then you type something, you get auto-completion. You get the full IDE experience, right into Livebook. And now you plotted your first graph, and then if you want to do something more complex, you already have a starting point. And from here, you can start learning more about the library, right? But it's not only about plotting graphs. So we have this new library in Elixir called Explorer, which is about data exploration, right? So you work with really large amounts of data, like gigabytes of data. So, well, imagine you want to do that. You can add a data transform smart cell, right? And here it's saying, hey, I don't have a variable that I can work with. It gives an example for us to work with, so let's define that variable. Here, yeah, so it has some sample data for us to play with. And now here, I can just say, well, okay, yeah, I want to, so the iris data set is a very known data set that has information about flowers, but we can start playing with this idea here once again. Say, okay, I want to get where the length is more than 0. It's a silly example, right? The length is always going to be more than 0 for a flower, but we can go, we can run it, we can start filtering the data, we can group information, so we can say, well, let's say I want to group by the species, because we have different species of flowers in the data set, and I want to summarize this data by getting the mean of the length and the width, right? So you can start playing with the data, right? And starting getting information that you can do whatever you want later. You can plot it, whatever you want to do. And once again, you're saying, okay, I got started, but now I have to use this library in my actual application, right? And then you can get the source code, and you can learn how to use the library and how to write those queries, right? Last example I'm going to show about smart cells is machine learning. So yeah, Elixir can do machine learning stuff now, really cool, but how are you going to get started? Neural network task, boom, and then there are a bunch of tasks that we can do, all those tasks, and then I want to do something like speech to text. So I just configure which model that I want to do, and I evaluate. And what this is going to do, I hope, I hope it's not downloading the data set, because that's going to take a while. Yeah. Oh, I did something wrong here. Oh, yeah. Good point. So let's solve this problem by removing the cell. Something got stuck. And now it has to, we kill the runtime because that cell got stuck, and now it has to evaluate everything again. But wait, something is going horribly wrong, because now it's not installing the dependencies either. Hold on, let me, yep, we are back. All right, I'm going to just evaluate the cells very quickly. This is going to break. This. All right, so now you're good. All right, so let's say, okay, we want to do a machine learning model, right? So you can choose, yeah, speech to text. You can choose that as an example, right? And then what it's going to do is that it's going to set up both the machine learning model and the form for you to interact with the machine learning model, right? So I can come here and I can say, hold on. Hello, darkness, my old friend. And I put the audio, I submit it, and the first time it's going to compile the module, it's going to do everything that's necessary. Well, my accent screwed that up a little bit, but yeah. Hello, darkness, my old friend. Yes! Right, and once again, you want to check out the code, you can check out the code, right? And we have examples of getting the code from a machine learning model, putting that into a Phoenix application, and running that in production, right? So that's really cool, really nice. And again, everything is just processes, right? So we have the browser, it connects WebSockets to the Livebook server, and your code that is running the notebook is a process. The smart cell is a process. All the outputs, they are processed as well. And that's why we can be interacting with all those things at the same time. So, all right, before I finish this talk, there is one last thing that I want to talk about. Something that we have started exploring, but we have not yet achieved the full potential behind those ideas, which is the idea of leveraging Livebook more and more for live programming, right? So who here has used DBG before for the new debug stuff? Has anybody used DBG in Livebook yet? All right. So for example, DBG allows you to print like the result of a pipeline instead of steps of a pipeline. So when you do that in the terminal, it prints the result of each step. And it does the same in Livebook. But again, because Livebook is a rich medium, what does it mean to print a pipeline in Livebook? This is what it means. It prints the pipeline, and you can actually go and change the order of the operations to see how that affects the pipeline, right? So you can turn things on and off to see how and every time you can see how the result changes, right? Every time you are doing this, right? And then you change the order, and you're like, oh, maybe there is a bug because I figure out that if I put Elixir, like maybe we want to get the first word without bang, and then it's like, okay, how are we going to change things in order to get these results? We can explore with all those ideas, right? And then after you change the pipeline, maybe you get a solution that you're happy with. You can copy the new pipeline, and you can put it in place. And now, boom, you have your updated code. Is this going to work? Well, yeah, the code at the end is wrong, but the idea is sound. Right, the other thing that we can do, and this is an example from Ryo Wakabayashi, who is also giving a talk at the event, which is like, well, we can also work, again, it's all about rich visualization. So we can also work with images. So we can download this image from the internet, right? And then you can say, well, I have this pipeline using OpenCV that is manipulating the image, right? And this is the image that we get at the end. And then you're like, wait, no, this is not quite right. So once again, we can come back here, right? And start changing the pipeline. Well, let's remove the blur, right? Oh, okay, that's better. Maybe I want to rotate after I put the ellipse, and that's closer to the dog. So you can go and start playing with those ideas, right? All through the pipeline, and it works with any kind of rich media. If you have like a table where you're processing a bunch of things and you wanted to study the process, like the operations in the middle, you can do all of that, right? And the last thing, so when I said that there's still a lot to explore, right? So DBG is really cool, but one of the things that we in the Elixir community, we're very proud of documentation, of writing documentation, right? Really good documentation. And if we're using Livebook to teach somebody about Elixir, it would be nice if we were telling them like, hey, write documentation to your functions, right? That would be fantastic. And then we can write documentation to the functions and you can access them in Livebook, which is really cool. But we also focus a lot on tests. And one of the features that we like a lot are doc tests. So we can write examples in our documentation and to show how to use our APIs and verify that the examples are valid. Well, if we have Livebook, what could we do, for example, if we could, every time, it could automatically detect that they are doc tests and run them for us from every cell. And that's exactly what are happening here, right? So we just started exploring this idea. You can see here that the output is just printed to the terminal, but there are so many things that we can do. We can like show in status here now, close to each doc test, saying, oh, it's green or red, have ways of putting the result close to the code. And that's what I wanted to talk about today, right? That's what I want to show. Is like now having this rich medium. It allows us to explore ideas in different ways, and we are just beginning. And the cool thing that those things are going to trickle down, right? So when we start adding those tools to Livebook, for example, they can be incorporated into IDEs. And I think that's very exciting because before, when I was working on Elixir, I would always think, well, people are going to use Elixir from like an IDE or from a terminal, right? I did not think about this rich medium where we can interact with outputs. And I'm constantly thinking about this, like, well, we have this feature. And if we use it in Livebook, how that's going to look like. So yeah, that's what I wanted to share for today, those ideas about bringing Elixir to life. I hope you have enjoyed it, and I hope you're going to have a great conference. Thank you. Yeah, we can, if we have time, we can do, yeah.
Wow, great. I think the chat introduction undersold that, so that was great. We have some time for questions. Does anyone have some questions for all this? No? No questions for Jose?
Yes, there's one there.
Well, great talk. Thanks a lot, Jose. So maybe a newbie question. So there is Jupyter, right? Jupyter Notebook.
Yeah.
And I'm just wondering, why did you decide to, introduce a new one? Why not to extend that one?
Yeah, so the question is about Jupyter Notebooks and why we decided to create a new one. So, okay, I'm thinking, all right, we're going to go with long answer. So, so there are a couple reasons. So one is like, Elixir has been really good. So one is like scratching our own itch kind of thing. Like we want to build something like that because we have a really nice platform for building web applications, and there's live view. So we wanted to build something really complex with live view to show that it works, that it's scale for complex apps. So there was that part of scratching our own itch. But the other thing is that I actually wrote this for the presentation and I removed it in the interest of time. But with Jupyter, the way that Jupyter Notebooks, who here has used Jupyter Notebooks? All right, amazing, yeah. So Jupyter Notebooks, they started with Python, but you can have runtime for other languages. But the way that Jupyter Notebooks work is that you can think that you have some global state, and every time you execute a cell, you are getting that state, doing some operation on it, and putting it back, right? So for example, I'm going to show some examples here. Right, so imagine that you have this, right, x equals 1. So if you think of in Jupyter Notebook, that would like set the variable there in some state. And then if you say like x equals x plus 1, you want to increment it, it's 2. But in the Jupyter Notebook, if I executed the cell again, every time I executed it, the value would increase. Because it's global state, the cells are basically like getting things from that state, changing it, and putting it back. And the things that we don't like global state, right, that make things hard to represent and to understand, to the point that people say one of the biggest issues with notebooks in Jupyter is reproducibility, right? Because if you imagine that every time I execute this cell, this value change, how am I going to share that notebook with somebody else? I'm going to say, hey, execute all the cells, but when you get to cell 4, remember to execute it twice, right? It's not very helpful. So this was also a good opportunity to like think from scratch about some of the problems that they are there. And now that we are in a functional programming language where things are immutable by default, like maybe we can have new solutions to this problem. So for example, and the thing is that in the Python community, there are attempts at solving this problem, but because everything is mutable, like if you mutate an object, that is a state in your notebook, and that's going to be there. There's no way you can work around it. So in Elixir, the way that Livebook works is that the whole evaluation is sequential. You execute everything from top to bottom. There is no out of order execution. But because because everything is immutable by default, we can do like cool things, like co-analyze. So for example, imagine that I have x equals 1, y equals 2, and now I define a new cell here that is the result of x plus y, right? So one of the things that we can do, for example, is that we can analyze the state and the dependency between the cells. So for example, I have x equals 1, y equals 2, and I change this cell here, and I evaluate it. So we know that the value of x changed, but we can see this, and then we can see that x plus y, now it's stale. It's telling us, like, hey, you change something that this cell depends on, so you may want to reevaluate that. But y equals 2, we know that that thing doesn't depend on x. So we know that that thing is not stale. So this is a great opportunity to think about some of the problems and have a tool that is more tailored for us. And like some people have asked, like, are we planning to bring this to other languages? And I think the truth is that Livebook is really useful for functional languages. I think the general imperative language is not going to be that useful because a lot of our infrastructure is built around the fact that, yeah, we can understand the language and we know that things are immutable by default, so we can leverage all those types of properties. Yeah, thank you. There are probably other reasons like smart cells. It's something like that it's also very specific to how Livebook works and so on. So there are other reasons, but I think those are the main ones. Thank you for the question, really great.
Hey, good morning. Thank you very much for the talk. I have a question about Livebook and the neural networks. And I have a little problem still to wrap my head around how to deploy something like this to production. So where would I run my neural network? And I wanted to ask, is there maybe something coming up in like to show how you can really bring this to production and use it in production as well?
Yeah, so it's a great question. There are many options of how you can do this. And I think one of the exciting things about machine learning in Elixir is that when it comes to deployment, you have all those options available that you don't have in the other languages and platforms. So I published a video last week called Distributed Square Machine Learning with Elixir. And the idea is that with Elixir, so for example, let's think a little bit about like Python, for example. Like with Elixir, with Python, you could run the machine learning. For example, you have a web app, it does machine learning stuff. You can run the machine learning model within your Python process, for example. But usually when you are deploying a Python system, you are starting, like if you have a machine with 8 cores, you are starting like 8 instances of this machine, right? So you don't want to start like 8 ML instances, one for each process, right? So usually your option when you're like, hey, I want to do ML in production, your option is, yeah, you're going to put that ML model on a separate server. Maybe you're going to pay somebody to host that AI model for you, which is a very sensible option. It's something that we can do in Elixir, but your options are usually around there. But in Elixir, because if you have a machine with 8 or 20 cores, you can actually just have that and have the model collocated with your Phoenix app and just run those things together. So that's one option that you can do. And it's all going to depend. It depends on many factors. It depends on the model size. Because if you have like a really large model, you're probably going to need GPUs for that. So you have to, there is a cost equation on that. Like, do you want to have things on the same server or different? So you have to consider, but you have the option. You can run on that same machine, regardless if you have GPU or not. But you can also run on a complete separate server. But the things that we added with NX now is that I think you have to change 2 lines of code or something like that. You can have a model running anywhere in your Erlang cluster. So what that means, for example, is that Fly, if they support GPUs, for example, what you could do is that you could deploy your Phoenix application on Fly, and then you have like Phoenix instances in different places around the globe, and then you have 3 machines with GPUs in there. They're all connected in your Erlang cluster, and it's just going to work. All you have to do is like change 2 lines of code or something like that. So the idea is, I don't think there is an answer. It's going to depend on the model size, your problem, what is your flux, and I think we're going to your flux of requests. And I think we're also going to learn more as the community starts to really use it and deploy those things. But I think the good news is that we have a lot of options that we want to consider. So for example, like running in the same machine, it's very important for nerves, right? Because in nerves, if you want to run like machine learning on the device, that's your option. You have to run everything together. And we can explore all those possibilities and combinations. Thank you.